Hi everyone, this is Charles Song from Data Platform at Lyft. It's very nice to be here again this year, and this time I'm going to share you some news about how we are pushing Trino as the #1 query engine at Lyft in the past year and going forward. So as you may know, Lyft has been an early adopter on Trino, and we've been really pushing forward to the latest Trino versions and the largest scales with Trino. And today we're going to talk about briefly the basic Trino infrastructure at Lyft. And then we're going to do some basic comparison versus some other query engines, especially Spark. When are we going to use those query engines in different scenarios? And I'm going to talk about why we are looking for faster query engines and what it means to our customers or to our business. And in the end, I will show you some key numbers and factors that why we are confident that pushing Trino to this position and how we are making it. In the end, I will mention some future work that we believe we'll be working on, potentially exploring to make it a better query engine at Lyft and to make the use case for data engineering and machine learning engineering better across the company. So first of all, the Trino infra at Lyft has been relatively staying the same over the last year. You will see this picture in the presentation last Trino Summit as well. We add some new and cool features, but overall it's the same in high level. So from right to the left, we have a different Trino clusters. We have ad hoc cluster for interactive queries, which meaning query finishing within minutes. And we have ETL cluster suitable for longer running queries. Queries can run hours with terabytes of input volume. And specifically, we have a schedule cluster, which is for dashboarding and reporting, which is surprisingly one of the largest use cases using Trino right now. And within each Trino cluster, besides the basic coordinator to worker connections, we also have an established autoscaler attached to each cluster. So our Trino clusters can scale up and down accordingly to the real-time volume, which is a big plus to the overall Trino architecture here because it's basically saving a lot of cost, improving the Trino query efficiency, and most importantly, it increases the reliability of Trino queries when there's a peak volume or large queries with noise neighbor problems. On the middle of the graph, you're going to see we have a Trino Presto proxy, and it's basically a router or load balancer, whatever you call it, and it's backed by Presto gateway. Nowadays, it's a Trino gateway. We have various in-house customized routing rules, which is handling different user clients and use cases to make sure the right use case will be routed to the right cluster, which is very critical to the Trino overall performance because Trino is just using all resources aggressively and you need some intelligence beforehand to make sure you're using the right cluster for the right use case. On top of the Presto proxy, you have the Mozart gateway, which is our higher level gateway for different query engines. So earlier we have Trino, Spark, and Hive. Hive has been already deprecated at Lyft, so it's most likely Spark and Trino for majority of the volume for now. And you will see on the very left side, we have so many different Trino plans for different use cases. We have Spellbook for interactive queries, Airflow Flight for ETLs, data ETL, or machine learning pipelines. And we have different SDKs and toolkits to make sure we are able to query it programmatically from different services. And we have Tableau and mode reports for dashboarding purpose. So this is pretty standard, straightforward Trino architecture. So why I'm mentioning we are moving Trino to the #1 query engine at this company. So think about it. When we first getting to know Trino, for me, it was a couple of years ago. And the first question I searched on Google was that, how do I compare Trino SQL to Spark SQL and when should I use which? So I bet you, if you if you ever query this question, you got a similar answer as I did, that people saying Trino is good for interactive query because it's low latency. But for some longer queries or more complex queries, you're gonna use Spark, and because it's more reliable and was built for larger capabilities, so on and so forth. You didn't really get, or we didn't really get the tech details on why, and we were not, at least I was not fully convinced, because especially when I see how Trino is growing over the past few years, I was always wondering if this statement has been true for all the time. So for interactive queries, there's no doubt Trino has always been the better choice. It's easier to use for data engineers or other machine learning scientists, and it's low latency for, when we say latency, it's the execution time for queries. And people can get query results in seconds, which is super important for the user experience. Compared to Spark, you may get a simple stack start for query and running within minutes, which is also cool compared to other query engines, but not as fancy as Trino did. And for Spark, it's great for ETL because the complexity of the query and the design for Spark, and of course, high reliability, not only because the Spark is allocating the dedicated resource for each application, but also we have the multi-layer retraining mechanism. We have the task level retry, stage level retry, and using DAG to retrieve the failure DAGs, which is pretty important for the in-application retry mechanism. And Spark was proven to be able to handle larger volume, which is very important, which I think is the most important factor why people choosing Spark, because it has been proven in production environment for many other companies and industries. And when it comes to machine learning nowadays, people believe Spark has a lot of built-in query functions for easier aggregation and faster machine learning integration, because, you know, as a data scientist, you can always write Python with PySpark, SQL, and then write machine learning in Python as well. So it's easier to integrate as well. And sometimes you can even use the same container for data aggregation and the machine learning model building, so which is pretty cool actually. But I would wonder if they are still valid nowadays, given our experience at Lyft. Many of them can be changed or will be changed very soon with Trino. So what's going on here? When you use Trino, queries can be very complex nowadays actually. So you may or may not know Trino is limiting 50 maximum stages by default. That's just trying to push users to a good behavior or use case that you should never write too complex queries. If you do, you are looking for some ETL solution instead. But in reality, in some of our use cases, we do have special use cases where we have to run 100, 200, 300 different stages, which high level roughly equivalent to the DAX stage in Spark. And that's a lot of stages, and they can run smoothly and with high reliability and success rate. And regarding reliability for ETL queries for Trino, we've been wondering how Trino can be reliable for long-running queries. If the query runs for 3 hours and one of the steps fails, what happens to Trino? So first of all, what's happening nowadays is that with Trino queries, query rarely fail for no reason. So query can run for 2 hours, 3 hours with high reliability, and it never fail actually, at least to our experience in production environment with a lot of data volume. And additionally, there was the project tardigrade release for Trino, which was really making Trino to the next level about fault tolerance and reliability, you can have a task level retry. And we've been tested it and it worked out very great for a lot of edge cases and recovering failed queries in real time. And again, people worried about Trino handling larger and longer queries because it's never proven. And in our experience, it's already proven because we've been using Trino query tens of terabytes of tables or queries every day. That's a lot of query, and there has not been any problem with it. The only problem I would say is that how we allocate memory and CPU resource, especially memory resource for different queries, because when we are running Trino, we want to have shared resource for different queries, and there will be a limited per node memory limit, which can't be a limit for different queries, larger queries. Regardless of size, we haven't really seen any other blockers for pushing the query volume to the next level. And for machine learning, it's quite interesting that we also can build our customized query functions in Trino. That's not a problem and easy to do actually. And besides that, when we talk about machine learning data aggregation, yes, we can only write SQL queries with Trino for aggregation. Sometimes it's noisy and annoying to write SQL queries compared to, for example, I write Scala a lot before, and it's easier to read and easier to understand sometimes, and same as Python. But if you are able to write SQL queries, and Trino can make it much faster than Spark, which it will make a different decision for your machine learning data aggregation part. That imagine when you have a machine learning data aggregation with Spark for running for 1 hour to collect and aggregate data for the machine learning model training, and now you have just 10 minutes aggregate all the data results. And we are assuming all the aggregated results will be smaller than the input volume. So there's not huge cost when you moving those aggregated data around to another container for model training. So that makes a potentially much better choice that you aggregate data with Trino and then train your data with your Python container in some other containers. And overall, the development experience will be much smoother because a lot of time you spending time tuning your queries, and now you don't have to because it's very fast. And for our experience working with a lot of data scientists, data engineer, machine learning engineer, or general software engineers, the most painful part, for example, for Lyft, we have red share tables and session tables. When we talk about red share, it's a lot of dimensions and columns. Some table can be super large with super wide, with hundreds of different columns, and the data exploration and query testing can be so long, taking a couple of days or several days, even over 1 week. And in that time, imagine when you have individual query tested for 1 hour each time in Spark, that's gonna be a disaster. You're gonna run and test your query a couple times a day, and then spill over to the other day and continue the same thing and the other day. But if you run everything in Trino and we'll be able to test within, let's say, 10 minutes for data sampling exploration, maybe even faster than 10 minutes in reality, you're gonna able to test your query 20 times, 30 times a day. And that's really smoother developer experience and really making a big difference here because you're gonna test and deliver your data aggregation part of your pipeline within days or within 2 days. And that's going to really boosting your overall delivery time for your production pipeline and eventually push the delivery time for your business or business decisions. That's really critical to our experience, and that's how people loving Trino. Actually, people by default starting to use Trino for testing. Even so, we know some engineers will eventually convert Trino query to Spark query in production, but they will always use Trino for testing. That also tells something. So some key numbers for Trino at least. So Trino has nowadays reaching the peak of 100 petabytes data read volume level, which is 10 times larger than where it was last year, and 10 times larger than the Spark SQL volume with comparable infra cost. Imagine we are just doing 10x work with the same amount of dollar cost versus Spark SQL, which is pretty crazy in my view. And for reliability, this year we also made a huge progress with the newer Trino version and all surrounding puzzles supporting it, that we are reaching 0.01% infra level reliability issues. What does it mean? So it means we rarely see infra level issues or noisy neighbor problems because it's really rare. The number to compare that before 2022 or even before 2021, we were at somewhere with 1% or 0.5% failure rate for infra level reliability issues. And right now, with all the surrounding puzzles, Autoscaling, replayer, a newer Trino version, we gonna reach such a low reliability issues, and it's already lower than Spark failure risk, which is making Trino the most reliable query engine as well. And also, as always, we can serve consistent second level latency for smaller queries. Even so, within Lyft, we call it a 10 minutes SLO. We say we never guarantee anything within 10 minutes. It can be 10 seconds today, and it can be 10 minutes tomorrow with the same query, hypothetically. But in reality, we are leveraging it as a consistent second level query engine because people will benefit from it. And we are expecting, in reality, we're expecting second level latency for many small queries, and it's been really running well. It's like real-time query engine. Of course, technically, we cannot push it further without any other mechanisms like caching, but this is already good enough for a lot of offline, even real-time analysis. And we see very high success rate for long-running ETL queries. For those queries with over terabytes inputs or over 50 stages in the query, we've seen high success rate, and success rate surprisingly not lower than the smaller queries. So basically it's the same query, just running longer with a lot of resource. So that's great news and making us really confident that, okay, it's time to pushing Trino to handle more and more queries nowadays. And we've seen a lot of organic growth that people starting to use Trino to query tens of terabytes level queries and being successful in production. So we really haven't done anything specifically for this level. It's just by nature how Trino can handle this volume very well. And last year, I remember, including me, many of us complained about noise neighbor problems, that one special query can fail the cluster or fail many other queries. So this year, with all the new changes, I personally haven't seen many of them, probably a handful of them over the past year. We have one known error, which is related to our own infra. We are trying to fix it. But other than that, there haven't been really noisy neighbor problems. The only thing we see probably some super special query with skewed data will hit per node memory limit. That's probably all of it. All of those numbers are quite promising and convincing to the team that, hey, it's time to announce that Trino is definitely the top one query engine within the company, and you can basically use Trino for any kind of SQL query you would like to. And not like before, over the past few years, we were kind of ambiguous about Trino SQL versus Spark SQL. And we were kind of like the ChatGPT saying, okay, if you're interactive, you use Trino, and otherwise you can try Spark for higher reliability. I think it's not the case anymore, and we're confident saying, okay, Trino is also very reliable and handling large volume queries, which is very exciting for the team. And some key factors how we achieve that, and also some key factors or advice for some other team who is just joining the Trino world or still making progress at early stage, and they are actually ordered with priority. So first of all, a big lesson we've learned is that always keep your Trino version up to date. Again, this community has been pushing 30, 40 updates, releases every year, probably 30. And that's a lot of number with good features, performance improvements, bug fixings. And you really have to think about how to keep your Trino version up to date, especially when you have your local customers packages like we do. For example, we use Replayer for stress testing and load testing. So every time we want to upgrade to a new Trino version, we'll be able to test everything, verify the volume and reliability in 1 or 2 days without too many human interactions. This is really smoothing our Trino upgrade progress, and you probably can consider something similar because Trino new version is by default better than the older version in many of the cases. And the next thing, which is equivalent as important, is auto-scaling. You want to auto-scale your cluster because Trino is allocating resources aggressively, and all resources are shared across different queries. So without auto-scaling, you're gonna have to spend a lot of overhead on your query efficiency. And moreover, it's not about cost saving, it's about how you improve your reliability in your peak events. For example, for the highest peak day this year within Lyft, we received roughly 2x of the daily volume, and we didn't really do anything with our on-call engineers because Autoscaler really handles it with the high reliability. So reliability didn't even go down a single digit on that date, and we were able to handle everything just with Autoscale. And next thing is load balancing, proxy, whatever you call it. Right now it's already Trino Gateway. I'm personally very excited to see it is growing in such a approach and people can keep contributing to it. With load balancing, it's all about how you wisely routing different use cases to the right cluster. Nowadays, we still believe that different clusters have different priorities, and it will be used for different use cases. Not like Spark, you just allocate different resources for the applications in the same cluster. So a good load balancing strategy will make your cluster much simpler and faster and fault tolerant. So it's really, but also it's really taking time to understand your own use cases because it varies company by company in reality, and very hard to learn from others easily. It's not something like how we do auto-scaling. We have similar patterns in the industry. And the next one is fault tolerance feature, which is project tardigrade. It is very cool. We have stress tested it, and it performed very well, and really cutting down the reliability. But we haven't used it in production just because we're already comfortable with the super low reliability issue rates, even without it. So we decided not to push it to production yet, and we keep it as one of our strongest toolbox item. We can use it whenever we want easily because it's already tested within our infra. It's very easy to use if you're really seeing such issues. Just go ahead and try tardigrade. And also, let's get in touch because we also want to know when we will reach the case that we really have to use it. And the last, not least, very small item. So I always try the latest gravity instances. It's been beneficial, and to our experience, it's no-brainer to keep up to date with the latest version. So it's always cheaper with the faster performance, and just go ahead with it. There might be capacity issues on AWS side, but it's not your problem. Just try with it and talk to AWS collaboration teams on your issues. And I want to share diagrams about Autoscaling again, just in case you haven't seen it last year. So this is a typical CPU usage graph for one cluster receiving interactive queries. You can see queries are starting to grow in the morning time of the day, but it's very spiky. And with Autoscaling, it looks completely different, like some other software or service. So you can imagine what the difference in the cost efficiency and reliability change with this feature. And to be honest, developing a state-of-the-art autoscaling is not easy, but I would strongly recommend, if you haven't done anything, just at least try some script-based autoscaling, or even try cron jobs to scale your clusters, making it easier for handling larger volume and being quieter for smaller volume. And last, I want to share some ideas that we think where we are going at Lyft with Trino. So we are looking for better data pipeline or machine learning pipeline integration. We believe the development experience and the life cycle is critical. We shouldn't think data aggregation and the machine learning aggregation as two jobs, but considering them as one job, and how do we improve the overall experience. And we will keep pushing Trino's growth, especially for large queries, and potentially doing migration from other engines. But migration can be painful, so we are still evaluating that. Even before migration, what we can do is that just pushing Trino to be clear that as the #1 SQL query engine, and we are expecting new customer to be adopted into Trino SQL nowadays. And there has been a lot of new connectors improved or published over the year that we haven't got a chance to try. So we want to try those new clusters in the upcoming time, and making sure we provide flexibility to our end users. And given we have all volumes going into Trino, and that's the trend for next year, we're probably considering some other mechanism to improve Trino performance. Caching is definitely one, but it's something under exploration, because we are now comfortable with our Trino's position being still an offline query engine and support interactive queries in second level latency. So it will be some exploration with caching, but I don't think we are pushing to production in any time next year. And again, faster Trino upgrades. We have some infra to make it very smooth. We want to make it smoother, so every time we have no doubt, and any engineer from the team should be able to upgrade Trino easily without any problem. So that's basically everything about what we're thinking about Trino for next step at least. That's everything for this presentation, and I would thank you for your attendance. And if you have any question, just reach out to me on Slack or over my email, and we are excited to see you there. Bye-bye.